Hello everyone, good evening. Welcome to Protrainy's demo session on STADDPRO. I would request Sir to start with the session.
Okay, good evening everybody. So this is a demo class for the course which the title for which is Manual Analysis, STAAD.Pro and ETABS. So in this course, what we are going to do, how we tailored this course is that the thing is that if you want to go into structural designing, in present scenario, you have to have some kind of proficiency in at least one of the designing softwares. This proficiency will get you in, right? Then due course in your with your career, you will gain more proficiency, and this is how it will work. But you have to have at least you have to be proficient in at least one structure designing course. So the most popular these days is STAAD.Pro. I'm sure STAAD.Pro and ETABS, these are the most popular software designing courses. STAAD.Pro is like you can use it for almost all of the structure designing problems. But when it comes to ETABS is mainly tailored for frame designs, and especially for high-rise structures, high-rise RCC structures. So that is the case. Now the thing is that as I'm telling you that you have to be proficient in at least one software. So for this course, we have chosen, we have settled on to STAAD.Pro and ETABS. But the thing is, if you are proficient, for example, if you are proficient in STAAD.Pro, and then now, first of all, you need to understand the difference between a drafting software and a designing software, right? Pavitra Chaudhary, please mute them. So what I was saying is there is a difference between a drafting software and a designing software. Drafting software is AutoCAD, it's ArchiCAD, it's right. So on these softwares, you are going to use these softwares. They are these softwares are very essential, not just in civil engineering, but almost in all streams of engineering. But the thing is, anyone can learn a drafting software. But when it comes to designing software, you have to be an engineer in order to fully implement the designing software. So you have to be an engineer, because drafting software is going to it is not going to provide you with a result. It is not going to do any analysis. Okay? If you are drawing a line, if you are drawing a rectangle, you are getting a rectangle. Okay? It is not going to, drafting software is not going to do any kind of calculation. But when it comes to designing softwares, these softwares are capable of doing calculations. Okay? What kind of calculations, what kind of methods they are using, I'm going to give you a brief description onto that as well. But this is the difference between a drafting software and a designing software. So anyone can learn and work on a drafting software. But you have to be an engineer. You have to have a working knowledge of structures if you want to work on a structural designing software. So this is one thing. Now, why we have included manual analysis with STAAD.Pro and ETABS? So it comes to, from my experience, from everybody's experience in Protrainy, it comes to our notice that students are not very proficient, especially the freshers who are about to move into the industry. They are not very much proficient in manual analysis methods. Now, why manual analysis methods are important in this age? Because again, designing softwares are going to do calculation. So if there is a calculation, you have to be capable of checking onto that calculations. Not all calculations, but ठीक है, उसमें से कुछ भी उठाकर you can verify it. So for that you have to have proficiency in manual analysis as well. So this is why we tailored this course as such. Now, so let's start with our demo class. So these are the objectives and prerequisites for why to join this course, and what you have to have before you are joining this course. So objective is to make you more certain about the basics of theory of structures, then to make you proficient in manual methods of structure analysis, to make you confident in modeling and analysis using STAAD.Pro and ETABS. Prerequisite is this is the basic thing. Students attending this course should be at least aware of basic knowledge of mechanics. Okay? You have to know basic mechanics. What is motion, and how, if you are changing, if you are, अगर आप किसी बॉडी का उसका पोजीशन में चेंज आता है तो उसकी वजह से उसमें what mechanics is involved into that. So this is the prerequisite. Now this course content will be like this: bending moment, shear force, bending moment and shear force, then fixed beams and moment distribution method, building frames. So this is the bending moment and shear force. It's the most basic thing. Okay? If you don't know how to draw a bending moment diagram or how to draw a shear force diagram, then structure is not for you. Fixed beams, the most commonly used form of beam, continuous beams and fixed beams. So fixed beams, we have included fixed beams. Then comes moment distribution method, because it is the when it comes to manual method, there is slope deflection, then there is double integration, then there is moment distribution, and another methods as well. But moment distribution method is widely used. It is like it's tried and true. Okay? So that is why we have included moment distribution method. You can use it for a single continuous beam, or a single fixed beam, or you can use it for portals, multi-story portals. So this is frames. Okay? So it's like, you know. Then comes building frames. Next, then we are going to move into STAAD. So STAAD mein, what we are going to do is first a brief intro about the to get you acquainted with the interface, how exactly STAAD works. Then how to create a model in STAAD, how to apply loads onto it, how to make your model as realistic as possible. ठीक है ना? क्योंकि what is happening is आपने model बनाया, you have to keep in mind कि this model is representing the actual construction on the site. So you have to make it, if you are making it more realistic, then you are going to get more realistic results. So that is it. And then same is with ETABS. So now let's move on to what is the content of today's lecture. So first we start with introduction to basics. From applied mechanics, I have taken these terms. Then first is force. We force hai to structural engineering hai, force hai to mechanics hai, right? Everything is about, what is the magnitude of this force? What are the reactions to this force? So basically this is the question. When it comes to structure analysis, when it comes to theory of structure, when it comes to mechanics, अभी कहीं या तो कहीं फोर्स लगाया गया या कहीं फोर्स के एक्शन को रोका गया है, तो इसके ऊपर ही it depends everything on to this term force. So force is defined as an agent which produces or tends to produce, destroys, or tends to destroy motion. Either it produces motion or it destroys motion. अभी मोशन प्रोड्यूस करने का मतलब ये नहीं है कि उसको आपने एक्सटर्नल किसी चीज पे पुश किया तो इट हैज टू मूव, राइट? इफ देयर इज अ रेलवे कैरेज on a railway station and if you are pushing onto it, it is not going to move, but that doesn't mean there is no force. आप force लगा रहे हैं, that is, but ये force, it is not sufficient to move this railway carriage on your own, but force is there. ठीक है? So what is happening is कि railway carriage is providing counter to that force. जब एक point आएगा when you overcome that force, the counter which is provided by the railway carriage, it is going to move. This is how force works. Then resultant force. If a number of forces P, Q, R, etc. are acting simultaneously on a particle, then a single force which will produce the same effects as that of all the given forces is known as resultant force. ठीक है? जरूरी नहीं है कि on a given point there is every time you are going to you have to face just single force. ठीक है ना? There are going to be more than one force. So in that case, how to find the what to do then? So what you have to do is you have to find the resultant force. Then comes moment of a force. So what is moment of a force? जो beam theory है, या when we will be talking about flexural members, the members which actually bends, so that is all about moment. So what exactly moment of force is? It is the turning effect produced by a force in a body on which it acts. Force is acting on a certain point, ठीक है? So उस point, but its effect is going to be, अभी अगर force किसी beam का span is L, उसके ऊपर force is acting X from support A, या फिर let's say it is acting on the center of the span at L/2. अभी due to that force, उस particular section पर, the section अगर हमने imagine किया at L/2, वहां पर क्या हो रहा है? ठीक है, you can find it. But because of that, because of application of that force, पूरे सेक्शन पे क्या क्या हो रहा है? जितना हम फोर्स से दूर जाते जाएंगे, the point of application of force से you can move in either direction. उस केस में उस फोर्स का इफेक्ट क्या हो रहा है? That is what you call moment. Then conditions of equations of equilibrium of any system of force. ठीक है? So it's a base. These are the basic conditions. Sigma h is equal to 0, v is equal to 0, and summation of m is equal to 0. इसका मतलब summation of all horizontal forces has to be 0, summation of all vertical forces has to be 0, and summation of all moments has to be 0. These are the three conditions of equilibrium. अगर कोई body is in equilibrium state, तो इसका मतलब है कि ये तीन जो conditions है, अगर ये satisfy हो रही है, then your physical body is in equilibrium. Now comes stress. अभी force is अगर उसको properly define करें तो force जो हमारे structure की बात करें तो it is something external. ठीक है ना? It is happening, it is applying due to something, some external factors. तो ठीक है, वो हो गया force. अभी because of the application of that force, आपका जो भी element है जिसके ऊपर ये force apply हो रहा है, how it is going to resist to that force, that is what a stress is. होगा क्या जब force apply होगा? For example, again let's talk about a beam. When you are applying a force on a beam, or when there is a force acting on a beam at that certain point, or depending upon effect of that force, जब हम उस beam के span में either direction में move करेंगे, depending upon the effect of that force, उस beam के अंदर different sections पर stresses develop होगी. ठीक है ना? Stress is the resistance to deformation per unit area. That is what a stress is, due to the action of external force. और उसका expression for that is small p is equal to capital P upon A. जो force है उसका जो भी magnitude है, if you know the magnitude of that force, then you have to divide it by the area on which this force is acting. That is what stress. Then comes strain. Now stress is the resistance to deformation. But what if there will be a deformation? पहले तो उसने resist किया, but after that वहां पे deformation हो गया, force consistently बढ़ता गया और resistance को उसने overcome किया, and then there is going to be a deformation. So deformation per unit length is going to be is called strain. So stress and strain, these are again basic but very important terms. Next is elasticity. Elasticity is the property by virtue of which a deformed body springs back to its original position after removing the external force. अभी external force beam पर लगाया, beam में deformation आया, किसी भी तरह का deformation आया, then when जब वो external force किसी कारण से हट गया और आपका जो element है, it springs back into its original form or its to its original position, then it is elastic. अगर ऐसा नहीं होता है, so then elasticity is always there. ठीक है ना? हर एलिमेंट में, हर मटेरियल में इलास्टिसिटी होती है, किसी में बहुत ज्यादा होती है, किसी में बहुत कम होती है, but it is always there. So that is what elasticity is. Deformation of body, delta L upon pi upon AE. So that is just an expression for strain. Next comes modulus of section. Modulus, what is modulus of section? It is the quantity obtained by dividing the moment of inertia of a body about its center of gravity. The moment of inertia है body का, उसको divide किया about its center of gravity by the distance of the extreme fiber from the centroidal axis and is denoted by Z. That is what modulus of section is, or section modulus. अभी section modulus को यहाँ पे इसलिए बताया गया है कि section modulus plays an important role when it comes to structure design and analysis. ठीक है? Indirect तो you have to use section modulus, उसका कोई ना कोई उसका use आता ही रहता है, but when it comes to steel design तो उसमें तो you have to go for certain section, you have to choose the sections sometimes depending upon the section modulus. So that is section modulus. Now comes types of structures. Okay, so first is statically determinate structures. If the forces in the members of a structure as well as its reactions can be found by the conditions of equilibrium or the principle of statics alone, it is known as statically determinate structure. ठीक है? Determinate, you can determine it. तो हो रहा क्या है? Whenever there is a force, that means there is an action. You are going to get a reaction. ठीक है? तो जब भी कहीं पर भी आपने फोर्स अप्लाई किया तो यू आर गोइंग टू गेट अ रिएक्शन, वहां कोई उसका रिएक्शन हो ही रहा है. ठीक है ना? अगर वो फोर्स, इफ यू नो द मैग्नीट्यूड ऑफ दैट फोर्स एंड नाउ यू हैव टू कैलकुलेट कि उसका रिएक्शन क्या हो रहा है. सो इफ दैट कैन बी डिटरमाइंड बाय यूजिंग द कंडीशंस ऑफ इक्विलिब्रियम और प्रिंसिपल ऑफ स्टैटिक्स अलोन, तो हमारा स्टैटिकली डिटरमिनेट स्ट्रक्चर हो गया. अगर ऐसा नहीं होता है then it becomes statically indeterminate. Next is statically indeterminate structure. If the forces in the members of a structure as well as its reaction cannot be found out by the conditions of equilibrium, it is known as statically indeterminate structure or redundant structure. ठीक है? इसमें हमारे को जो equations of statics है, उसके अलावा deformation को भी include करना पड़ता है. ठीक है? तो वो those equation of statics, they are not enough in order to solve these kind of structures. ये भी दो तरह के होते हैं, internally indeterminate and externally indeterminate structure. चलिए, so after that basics, then comes supports. Why supports? What is the importance of a support? Because whatever reaction is going to happen it is going to happen at the support. ठीक है ना, रिएक्शन जो आएगा वो एलिमेंट, जहां पर वो एलिमेंट सपोर्ट, सपोर्ट का मतलब क्या है, सपोर्ट का मतलब है आपने उसको किसी ना किसी मतलब किसी ना किसी तरह के मोशन को रोका है. दैट मीन्स वहां पे सपोर्ट का जो बेसिक मीन है इंजीनियरिंग में, उसका मतलब ये है कि यू आर withholding motion in any direction. It can be translation motion, it can be rotation. ठीक है ना, तो अगर आप रोक रहे हो then it is a support. अभी जैसे ही आपने रोका वहां पर रिएक्शन, there is a reaction. ठीक है ना, आपने जैसे ही उसको रोका वहां पर एक रिएक्शन है, वहां पर रिएक्शन आते ही now it's a question of mechanics, और अगर स्ट्रक्चर, उसको स्ट्रक्चर के फॉर्म में देखे तो इट इज द क्वेश्चन ऑफ थ्योरी ऑफ स्ट्रक्चर्स. तो दैट इज व्हाट सपोर्ट इज. नाउ व्हाट बेसिक कितने तरह के सपोर्ट है. सो फर्स्ट वन इज मूवेबल हिंज सपोर्ट और रोलर सपोर्ट. मूवेबल हिंज सपोर्ट और रोलर सपोर्ट. सो इफ यू आर लुकिंग एट दिस सपोर्ट राइट नाउ, it's this beam is on, this section is on a roller. So now it's on roller, so it can move, it can translate. It can translate horizontally, but it cannot move vertically. ठीक है ना, horizontal movement is allowed here, but vertical movement is not allowed. Then again, because it's on a roller, you can see because of this force, it is rotating. At the support, there is a rotation. The rotation is allowed and translation is allowed. But हमने vertical motion जैसे ही उसका रोका, what is going to happen? There is going to be a reaction. आप रोक रहे हो तो you have to face a reaction. Now you have to find out the nature, the magnitude of this reaction. ठीक है. Then comes pin support. Pin support में हमने क्या किया, उसका horizontal movement भी हमने रोक दिया. There is no translational movement as well. Vertical तो रोका हुआ ही था, horizontal भी रोक दिया. Now only thing, only motion it is capable of is rotation. ठीक है, तो now we have two reactions. Because it's 2D, so we have one reaction, then we have two reactions. Lastly, we have fixed support. Fixed support में हम क्या कर रहे हैं? Fixed support में we are obstructing the rotation as well. मैंने rotation भी रोक दिया. So as you can see, this section is not rotating like this section or this section. ठीक है ना, यहाँ पर इसमें bending आ गई है. It is not rotating. So that is what you call. अभी जैसे ही vertical reaction थी, horizontal reaction थी, और जैसे ही rotation को withhold किया, there is going to be a moment. ठीक है ना, because what is responsible for rotation? Moment is responsible for rotation. So these are the
રીલ જોવાનું બંધ કર, પગ સીધા કર.
next is bending moment and shear force. After supports, we have bending moment and shear force. So bending implies deformation of a bar produced by loads perpendicular to its axis. That is what a bending is. Deformation of a bar, जैसे bar हुई या beam हुई या slab हुई, deformation of these elements by loads perpendicular to its axis. ठीक है ना, उसके axis के perpendicular load लगेगा, and then there is going to be a deformation which is called bending. Now there are two types of bending: plane bending and oblique bending. If the plane of loading does not passes through one of the principal centroidal axis of inertia of the cross section of the beam. सबको पता है कि भाई बीम का जो क्रॉस सेक्शन है उसमें दो एक्सिस होंगे, x and y. These are the principal axis, principal centroidal axis. अगर plane of bending does not pass through, sorry, यहाँ पे ये mistake है. If the plane of bending is passing through these principal centroidal axis, then आपका जो bending है, it is said to be plane or direct. ठीक है, अगर ये नहीं है, if that is not the case, if plane of loading does not pass through one of the principal centroidal axis, अगर वो x या y के अलावा किसी और एक्सिस पर plane of bending है, then that means your bending is said to be oblique. Okay, so bending and shear force, bending moment and shear force is always there, bending moment is always there. It doesn't mean आप किस तरह का element कर रहे हैं, ये these forces are always going to be there. But when we are talking about यहाँ पर these become significant, especially bending moment, when we are talking about flexural members. And what is flexural members? The members which resist any kind of deformation or which resist the external forces by virtue of flexure or by virtue of bending. जो bend होके उस जो force उस पे आ रहा है external force उसको accommodate करते हैं. ठीक है, तो basically beam and slabs, these are what flexural, these are generally known as flexural members. Now comes types of beam, types of beams. Abhi sare example we are talking about beams. So there, what types of beams do we have? It's a simple thing, cantilever, then we have simply supported beam, and then we have fixed beam. Cantilever and simply supported are comparatively easy. ठीक है, cantilever में तो फिर भी there is some complication in cantilever as per me, according to me, but when it comes to simply supported beam, they are relatively easy. तो ठीक है, this is a cantilever जिसमें एक end fixed होगा और एक end जो होगा आपका free होगा. One end is free and one end is fixed. So whatever resistance is going to be, this section is going to provide, it is going to be at this fixed end. यहाँ पर तो कुछ हो ही नहीं सकता, ठीक है ना. इसे तो जैसे जितना आपने फोर्स डाला, ये अगर it is going to deflect, so it is going to deflect. But जो भी resistance है वो provide कहाँ से होगा? That will be at the fixed end. So this is a cantilever. Then comes simply supported beam. This is a general figure of or a description of a simply supported beam. दोनों तरफ, एक तरफ pinned support, एक तरफ roller support है, but इसके अलावा दोनों तरफ pinned support भी हो सकता है, no problem there. But yeah, so rotation is allowed, translation is allowed in at one end, and so this is a simply supported beam. अभी when we are talking about RCC, जब हम reinforced concrete की बात करते हैं, तो it is very hard to find a simply supported beam in a RCC frame, ठीक है ना, because it is what is happening is जो casting होती है beam की, slab की, that is वो monolithic होती है, ठीक है. RCC में it is monolithic. जब वो casting monolithic होती है तो there is always going to be certain amount of fixity. तो इसका मतलब ये है कि purely simply supported beam होना it's not possible. So that is one thing. So basically what you are going to face when it comes to RCC, steel में ठीक है, you can design a connection जो कि simply supported की तरह आपका beam, it is going to act as a simply supported beam. But when it comes to RCC, it is very difficult to create a hinge. So उसमें basically what we have to deal with is fixed beams. That is why we have included fixed beam, जो एक अलग से topic इस में include किया है, fixed beams. So what is happening at fixed beam? At both its ends, there is no rotation, there is no vertical motion, and there is no horizontal translation. That is what a fixed beam is. अब होता क्या है, चलिए वो fixed beam में बताएंगे जब when we will go to that. So that is a basic intro about manual analysis and design. अब बात करते हैं हम STADDPRO. So first of all, STADDPRO is a tool for structural engineers. As I told you before, structural engineer is fine. If you are just an engineer and you know basic about structures, you can use STAD as well. But you have to be an engineer in order to use STADDPRO or any other design software. So this is how they form the word STAD, structural analysis and design. Okay. STAD is one of the first software applications in the world automating the work of structural engineers and liberating them from lengthy and tedious manual methods, hence enhancing their efficiency and boosting the construction industry altogether. Acha, to be honest, when you are talking about structural analysis and design, it is a very tedious work. अगर आप उसको लेकर बैठते हो, even with the help of these softwares, it is a very tedious. बहुत दिमाग लगाना पड़ता है, बहुत चीजें anticipate करनी. तो just imagine कि बिना STAAD के कितना मुश्किल, कितना boring और कितना tedious हो जाता हो, ठीक है ना? Without STAAD, without these softwares. Of course, there is always going to be Excel. उससे पहले जब computers का जमाना शुरू हुआ था, तो everybody is using, engineers are using Excel sheets, and still they are using, still everybody is using, and they are very efficient tool. But in order to prepare those Excel sheets, वो अपने आप में again बहुत time consuming, बहुत tedious काम. So STAAD के या इस तरह के सॉफ्टवेयर के आने से क्या होता है कि now you can be more efficient as a structural engineer, and now you can meet your deadlines. ठीक है? So it is a tool. Again, I am saying it is a tool. ठीक है ना? ऐसा नहीं है कि STAAD आ गया तो मतलब now you are a structural engineer just because you know the basics of STAAD or you are a very good modeler. इसका मतलब भी ये भी नहीं आप बहुत अच्छा मॉडल क्रिएट कर लेते हो. इसका मतलब ये नहीं है कि you are a very good structural engineer. But yeah, it's a tool. Now, how to use that tool, वो यहाँ पे सिखाने की कोशिश की गई. So why and how STAAD is better, and when I'm saying STAAD, I mean STAAD as well as ETABS. So वही वाली बात, for a simple 2D frame, जब हम ये एक simple 2D frame है, ठीक है ना? There are two stories, but it's a simple 2D frame. For a simple 2D frame, the most appreciated method is moment distribution method. That is why we have included moment distribution method, in which loads on the beams to be transferred to the supports at their ends. Simple सी बात है. इस बीम पर जो लोड आ रहा है वो यहाँ पे इसके यहाँ ट्रांसफर हो रहा है. इस बीम पर जो लोड आ रहा है वो यहाँ ट्रांसफर हो रहा है. और ये दोनों स्टोरी का लोड जो है फाइनली इट इज ट्रांसफरिंग टू द footing or to the ground. Each support partakes the portion of load as per its stiffness. ठीक है? अभी यहाँ पर it is all in symmetry. It is all in symmetry. Load भी symmetrical है. अगर इसका dimension suppose 9 by 9 inches है, it's a square of 9 by 9 inches. इसका भी 9 by 9 इंचेस है, तो ये दोनों जो लोड इस पर आएगा वो आएगा बराबर. इट विल बी इक्वल. बट अगर फॉर एग्जांपल मैं इसका डायमेंशन चेंज करके इसको 12 by 12 कर देता हूँ, सो क्या होगा? आई एम गोइंग टू इंक्रीज इट्स स्टिफनेस, एंड इफ आई एम इंक्रीजिंग द स्टिफनेस इट इज गोइंग टू पार्टेक मोर लोड. तब जो लोड का डिस्ट्रीब्यूशन है इट इज नॉट गोइंग टू बी even, वो चेंज हो जाएगा बिकॉज ऑफ द स्टिफनेस. सो एवरीथिंग, कोई एलिमेंट कितना लोड रेजिस्ट कर रहा है, जो ओवरऑल लोड आपके स्ट्रक्चर पे आ रहा है उसमें से कितना, कौन सा एलिमेंट कितना लोड उसमें भाग ले रहा है, इट डिपेंड्स अपॉन इट्स स्टिफनेस. सो दिस इज व्हाट स्टिफनेस इज. K is equal to E I upon L. अभी इस केस में in which only I of the section is variable. ठीक है? स्पान तो जो है वो है, जो आपका स्ट्रक्चर है, आपने जो स्ट्रक्चर प्लान किया है, स्पान is there. If you have to provide a beam of certain span, then you have to provide a beam of certain span. You can't just shorten it. ठीक है? So that is one thing. Then comes modulus of elasticity, E. Modulus of elasticity depends upon the material, whether you are using concrete, whether you are using RCC, or whether you are using steel. So it depends upon the material. So again, so whatever material you are going to choose, uska jo modulus of elasticity hai, it is going to stay the same. भैया मैंने steel choose किया है, तो steel का जो है वही लेना पड़ेगा. It is again fixed. So only variable is I, moment of inertia. And why it is variable? Because it depends upon your lateral dimension. ठीक है ना, आपका जो सेक्शन का डायमेंशन है, डेप्थ कितनी है, उसका विड्थ कितना है, उस पर डिपेंड करता है. सो दैट इज द ओनली थिंग वेरिएबल. So it is all fine up to this, up to the, jab tak it's a 2D frame. But when you move into 3D frame, and this method falls short in delivering the solution in an efficient manner. बहुत ज़्यादा tedious हो जाएगा, बहुत ज़्यादा time consuming हो जाएगा. यहाँ पर आता है STAAD. Now enters stiffness matrix method. ठीक है, 3D में करना है तो you have this manual method as well, stiffness matrix method. But इसको manually करना just with the help of your calculator, it's not possible. उसके लिए this is the equation, P into K into del. So force matrix is P, stiffness matrix is K, and displacement matrix is del. इस केस में force matrix जो है that is partially known. I am just estimating that these forces are going to act on my structure. ठीक है, जितना मैं experienced हूँ, I can be good in that estimation or bad in that estimation, but again it is just an estimation. Then comes displacement matrix. Now depending upon that force जो मैंने estimate किया, I am estimating कि भाई because of this force ये वाला structure, ये वाला element इतना load bear करेगा, ऐसा होगा वैसा होगा, उसका displacement इतना होगा. Again this is partially known. ठीक है. What is fully known is stiffness matrix. Why it is fully known? Because इस पर मेरा पूरा control. Span is in my control. Modulus of elasticity मतलब material choice of material is in my control, and section is in my control. So stiffness matrix is fully known matrix. Now with above matrices, using the method we can solve the system for unknowns. Okay, using stiffness matrix method. So we can get reactions. And now we have reactions. Hence, shear force diagram and bending moment diagrams can be generated. And with displacement of different nodes be known, अभी displacement भी पता लगा दिया मैंने, reaction पता लगाया तो I can generate shear force and bending moment diagram. Displacement पता लगाया तो the displaced and deflected shapes can be generated. ठीक है, तो stiffness matrix method ने ये चीज कर दी. But now again I am telling you that it's अगर आप लोगों ने पढ़ा भी होगा definitely final year में, तो it's a very टाइम कंज्यूमिंग मेथड. उसको मतलब मैनुअली पूरा का पूरा कर पाना, इट्स नॉट फीजिबल. पॉसिबल तो है बट इट्स नॉट फीजिबल. As the case with all structural analysis method, this one is also extremely tedious and is not feasible for manual calculations. But with STAAD, that is not the case anymore. STAAD या ETABS, they are all finite element FEM based, so they are using this method. यहाँ पर कंप्यूटर का यूज हो रहा है, जो कंप्यूटर का जो एनालिटिक्स है उसका यूज हो रहा है कि वो जो एनालिसिस, वो जो कैलकुलेशंस इसको करने में हमें पसीने छूट जाते हैं, वो आपको ये सॉफ्टवेयर मिनटों में करके दे देते हैं. सो वर्क फ्लो फॉर स्टैड. सो स्टैड हो या ETABS हो या कोई भी एनालिसिस सॉफ्टवेयर हो, दे ऑल वर्क ऑन द बेसिस ऑफ गार्बेज इन गार्बेज. आप क्या फीड कर रहे हो, आपको उसका जो रिजल्ट मिलेगा वो उसकी क्वालिटी डिपेंड करती है आप इनपुट क्या दे रहे हो. what are you feeding? If you are feeding garbage, you are getting garbage. So input file, क्या क्या है इनपुट फाइल के कंपोनेंट्स. मॉडलिंग द स्ट्रक्चर. अगेन मॉडलिंग द स्ट्रक्चर, इट्स ये अपने आप में इट्स अ फील्ड. यू नो, अगर आपने देखा हो तो दे आर आस्किंग फॉर टेक्ला मॉडलर्स. ठीक है ना, मॉडलिंग इज अ फील्ड इन इट्स ओन आज की तारीख में. सो मॉडलिंग द स्ट्रक्चर, देन अज्यूमिंग एंड अप्लाइंग सेक्शंस, कन्फाइनमेंट्स टू द मॉडल. जो मॉडल आपने क्रिएट किया है उसके लिए कौन से सेक्शन अज्यूम करने हैं. if you are a newbie, you will be your boss will told you or your mentor will told you. Then जैसे जैसे आप experience, you are gaining experience, आपको अंदाजा हो जाएगा कि भाई इस तरह का स्ट्रक्चर है, तो इसमें मेरे को 12/18 का कॉलम लगाना है, 12/24 का कॉलम लगाना है। देन उसके कन्फाइनमेंट्स, उन सेक्शंस के क्या कन्फाइनमेंट्स होंगे, कहाँ पे बीम भिड़ेगी उसके अंदर, कहाँ उसकी इफेक्टिव लेंथ कितनी रह रही है। सो दिस इज ऑल अगेन इट्स योर डोमेन, सॉफ्टवेयर इसमें कुछ नहीं करेगा। देन कम्स डिफाइनिंग एंड अप्लाइंग लोड्स ऑन द मॉडल। आप क्या लोड अज्यूम कर रहे हैं, रियलिस्टिकली क्या लोड लग रहा है, ठीक है ना। तो इसके बीच में जो वो बनेगी, जो सिंकिंग होगी, इट विल टेक टाइम, बट हियर वी कैन, देयर आर फ्यू थिंग्स जो कि होनी ही होनी, ये लोड्स तो लगाने ही लगाने। बाकी एक्सपीरियंस से आपने कुछ और सीखा, आगे कुछ और गेन किया, तो वो एक अलग चीज है। बाकी कुछ लोड्स तो कोड कह रहा है कि यू हैव टू अप्लाई दीज लोड्स। नाउ देन नेक्स्ट इज सेंडिंग दिस फाइल टू एनालिसिस इंजन। इसको एनालिसिस इंजन में भेज दिया आपने फाइल को, एनालाइज हो जाएगा। रीड द रिजल्ट्स एंड वेरीफाइंग दीज रिजल्ट्स। देयर इट इज, वेरीफाइंग दीज रिजल्ट। एनालिसिस के रिजल्ट को वेरीफाई करना पड़ता है। आप यू कैन नॉट जस्ट यूज जस्ट लाइक दैट, ठीक है ना। उस तरह का कॉन्फिडेंस आने के लिए यू हैव टू वेरीफाई दीज रिजल्ट्स। नॉट ऑल द रिजल्ट्स, पूरा का पूरा फ्रेम का जो रिजल्ट है, हर रिजल्ट को नहीं वेरीफाई कर सकते। इसका अगर वो करना होता तो फिर ये स्टैड का यूज क्या करना। बट कुछ क्रिटिकल चीज है, यू हैव टू वेरीफाई कि भाई मेरा जो आंसर आ रहा है मैनुअली मैंने जो किया है, और सॉफ्टवेयर जो दे रहा है वो कितना आसपास है। Sending the results to desired design engine. Then after analysis you can send it to desired design engine. ठीक है, किसी में अलग अलग डिजाइन इंजन होते हैं, किसी सॉफ्टवेयर में एक साथ ही वो इंटीग्रेट होते हैं। कंक्रीट डिजाइन, स्ट्रक्चर, स्टील डिजाइन, थिंग्स लाइक दैट। So that is all about STAAD. Next is ETABS. Now what is ETABS? As I was explaining before, ETABS is a special purpose analysis and design program developed specially for building systems. Building system के लिए है ETABS, ठीक है। It's sophisticated yet easy to use. So ठीक है, ये बात सही है। I am a big user of ETABS and SAP and softwares like from CSI. So it's sophisticated yet easy to use. In ETABS model definition is floor by floor. अभी ये कुछ टेक्निकल चीजें हैं, ठीक है ना। हो सकता है, मतलब ETABS is claiming के these are, ये जो पॉइंट्स यहाँ पे दिए है कि it's better than any other software available in the market, but डिपेंड करता है जिसको स्टैड की तरफ जिसका इंक्लिनेशन है, it can reject onto these points, but these points are there. In ETABS model definition is floor by floor, column by column, bay by bay, and wall by wall, instead of non-descript nodes and elements in general purpose programs. General purpose programs का मतलब यहाँ पर हो गया STAADs. This makes structural definition simple, concise, and meaningful. ठीक है. In most buildings, the dimensions of the members are large in relation to the bay width and story heights. Those dimensions have significant effect on the stiffness of the frame. ठीक है ना? ETABS corrects for such effects in the formulation of member stiffness, unlike most general purpose programs that work on center line to center line dimensions. चलिए, ये भी एक बात है कि जो आपका जो ओवरऑल डायमेंशन है, ETABS उसको भी कंसीडर, या आपको एक ऑप्शन देता है कि whether you want to use the overall span या clear span, इस तरह के ऑप्शंस ETABS में रहते हैं. So that is one more beneficial thing about it. ETABS is a completely integrated system. This means that you can create only one model of the floor systems and the vertical and lateral framing systems to analyze and design the entire building. So right now you can do it on STAAD as well. The integrated modules include drafting module for model generation, then seismic and wind load generation module, gravity load distribution module, finite element based linear static and dynamic analysis module, output display and report generation. Then comes steel frame design, concrete frame design, composite beam design, steel joists design, and lastly shear wall design. तो ये सारे modules आपके ETABS के software के part हैं. And this concludes our demo on manual analysis, STAAD, and ETABS. if you have any questions, I am here to answer. Otherwise, we have to conclude.
Sir, I wanted to ask that in STADDPRO and ETABS, which method of analysis is used?
Which method of analysis is used? What do you mean by that? I mean, मैंने बताया ना कि these are all finite element methods. They are all using finite element methods, है ना?
Much of it is not covered in BTech. That's why we.
Pardon?
Finite element analysis. Much of it is not covered. It is in ME, no?
Yeah. I mean, ठीक है. शायद as far as I know, कि BTech में you, while I was doing BTech, there was no even we don't get any introduction about these methods. I learned about these methods when I was doing my masters. अभी क्या situation, I am not aware of that.
Okay, sir. Thank you.
You're welcome.
Hello, everyone. I have shared one registration link in your chat box. So those who want to join for this course, like this all-in combo 3 course, so you can click on that registration link and enroll yourself for the course. Thank you.
The link is valid till?
You can find in chat box.
The link is there in the chat box. I'm sending it again.
It is valid till?
Okay, Pallavi, so let's conclude this demo for now. I hope to meet most of all 25 of you when we are going to have our first class.
Thank you,
Thank you and good night.
Thank you, sir. Good night. I request everyone, those who want to enroll for this course, there is link in the chat box. You can enroll for this course there only. And people who are taking this combo, all 3 combo course, you will get 100 rupees cash back also. For demo session, we do not provide